In this video, we're going to be talking about gas measurements. And given the pressure of a gas in several different units, our goal is we want to be able to convert between those units, and then also be able to define pressure, interpret statements in which the term pressure is used. So experiments with a gas typically involve measuring or controlling its volume, its pressure, and temperature. And the relationships between those variables were among some of the earliest experimental studies done in science. And unlike a liquid, the volume of a gas is the same as the container it's in. So that's easy. But the pressure and temperature of a gas deserve more careful consideration. So here's our example here. We're going to talk about it a little bit more detail in some slides to follow. But here's our definition of pressure. It's the force over some unit area. So the force exerted over some unit area. And in this example here, I'm just introducing a concept called atmospheric pressure. So this is the pressure kind of pushing down on us, pushing down on objects of the atmosphere. Okay, and in this example, we have this tube here filled with elemental mercury, and that's the symbol for mercury, Hg. And there's this little dish of mercury. And so the atmospheric pressure is pushing down on the mercury. And the mercury is in the tube. And so the height in this example of the mercury in the tube, the pressure of the mercury, I should say, is equal to the atmospheric pressure in this example. Okay? So we're going to do more examples of using this known as a mercury barometer, okay, in a few slides from now. Okay. So, but that's the concept of atmospheric pressure. So here's some common pressure units. Okay, you can print out this slide. You have it in your lecture notes as well and use it. But similar to before when we were doing dimensional analysis, we should be able to convert between all these different units of pressure. So here's an important one. This is an atmosphere. These are barometer-based units. Okay, so 1 ATM or 1 atmosphere is equal to 760 millimeters of mercury is equal to 760 torr. And if these units are unfamiliar with you, that's okay. We're going to be using them a lot. So you'll become more familiar with a torr or an atmosphere as we go through these different examples together. Metric-based systems like a Pascal, which is defined as 1 Newton, which is the unit for force, per square meter, which is the area. There's other units, like in the US, we might use PSI, things of that nature. So this is just a table, like I said, or a list, I should say, that will give you all the conversions you're going to need for the class for gases. Okay, so let's just do a sample exercise converting between one thing and another. It says the pressure inside of a steam boiler is 1,154 psi. Express this pressure in atmospheres. Okay, so we're going to use dimensional analysis. So we're going to write down what's given. Okay, which is 1,154 psi. And this should be very familiar to you now, writing down what's given and what's wanted. What's wanted, we want the units of atmospheres. So what's our conversion? Well, if we go back to the table, okay, we know that for every 1 atmosphere, there's 14.69 psi. So that's what we're going to use. So for every 1 atmosphere, there's 14.69 psi. Okay, so our path, we want to go 1,154 psi to atmospheres. Okay, so if I write that out here, I'll see 1,154 psi times every 1 atmosphere, there's 14.69 psi. Okay, units of psi cancel. And what I get is 78.56 atmospheres. Okay, so let me just check that in my calculator real quick. So 1,154 divided by 14.69, yep, that's what I get. All right, so that's just an example of using dimensional analysis to convert between these pressure units. And that's something we're going to do quite a bit moving forward. Okay, so here we go. So we're going to measure pressure in the lab, or let's say you wanted to do that. You can use an open-ended manometer. Okay, and this is an example of one here on both sides. And so the advantage of using millimeters of mercury, I kind of said that in passing, or the height of the mercury, is that it has a physical meaning, right? You can measure the mercury. Well, hopefully not, because nobody really works with mercury anymore, at least not where the university where I went to graduate school, Penn State, because they're trying to ban mercury because it's pretty dangerous. But and it gets everywhere if you drop it. But anyway, it doesn't matter. So, but let's say you're back in the day in the 1800s and you wanted to measure this using mercury in a tube. This is the apparatus that you would use, an open-ended manometer. So in effect, right, you can determine the pressure of a gas as measured using this apparatus by adding the pressure difference to or subtracting the pressure difference from atmospheric pressure. So let's look at this example. So you have here a lot of gas in this example, a high pressure of gas, and there's some mercury in this tube here, okay? And this end is open, so the atmosphere is pressing down on the mercury in the top of the tube. And so in this first example, the gas pressure is higher than the atmospheric pressure. So it's pushing the mercury kind of out of the tube, if you think about it that way. And so to get the pressure of the gas, you simply add the pressure of the atmosphere to the pressure of the mercury, okay? In the other example, where we have less gas here, and I don't know if you can see that in this cartoon, it kind of looks like less yellow to me, trying to illustrate less gas. The atmospheric pressure is higher than the pressure of the gas. So the gas, or the mercury, is kind of getting pushed towards the closed end of this apparatus, okay? So in this case, the pressure of the gas, to calculate that, is the pressure of the atmosphere minus the pressure of mercury. So how we could do this in our example is any time the level of the mercury is higher on the open-ended side, okay, of the apparatus here, you're going to add the pressure of the atmosphere to the pressure of the mercury. Anytime the level of the mercury is lower on the open-ended side compared to the closed-ended side, we're going to subtract the pressure of the atmosphere. Excuse me, we're going to subtract the pressure of the mercury from the pressure of the atmosphere. Whew, okay. So if that doesn't make sense, let's do an example together, and hopefully it'll make more sense after we do that. Okay, so find the pressure of the gas in the mercury manometer shown if the atmospheric pressure is 754.2 millimeters of mercury, and the height here, or the pressure of the mercury, is 30.1 millimeters of mercury. Okay, so first of all, we have this equation. So pressure of the gas is equal to pressure of the atmosphere, right? Plus or minus the pressure of the mercury, or the height of the mercury, same idea. Okay, so let's ask ourselves, right? Is it plus or is it minus? Well, if we look here, the level of the mercury is higher on the open-ended side. So that means the gas is basically has more pressure than the atmosphere. It's kind of pushing the mercury out. So we're going to add here. So the pressure of the gas is equal to the pressure of the atmosphere plus the pressure of the mercury, which is equal to 754.2 millimeters mercury plus 30.1 millimeters mercury. Okay, and when you do that addition, you should get 784.3 millimeters mercury. Okay, so there's a few examples that you can do, or there's one example, there's a few more examples, I mean to say, in your homework. So I'm just going to plug this in my calculator one more time. 0.1. Yes, and that's what I get. Okay, so finally, the last goal is about temperature, and we've already done this, but I want to bring it up here again for a very important reason. So we want to be able to convert between Celsius and Kelvin. And this is because gas temperatures are commonly measured in Celsius, but in problems that involve pressure, volume, temperature relationships, gas temperatures need to always be expressed in the absolute temperature scale of Kelvin. That's a key. If you don't convert to Kelvin, you're going to get the answer wrong, okay? Always convert to Kelvin. So Kelvin, the absolute scale, okay? We know how to convert between one or the other here. So do we have an example here? Yes. So the boiling point of bromomethane is 38 degrees Celsius. What is the equivalent absolute temperature? Well, remember the temperature in Kelvin is equal to temperature Celsius plus 273. So temperature Kelvin is equal to 38 plus 273 in this case, which is 311 Kelvin. Okay, so again, not that the example problem was particularly challenging here, it's just the fact that we need to be able to convert all temperature readings from Celsius to Kelvin in this chapter. Okay, so I believe that's it for this video. It is. And in the next video, I think we're looking at Charles' law.